Okay, we are going to find the algebraic expression that is equivalent to, let's look at number 39. So equivalent to the sine of 2 arc cosine of 3 over x. I'm going to use a highlighter here. Remember the arc cosine of a ratio. The arc cosine of a ratio is equal to an angle. So this is just another way to say, find the sine of 2 theta. And the sine of an angle is going to be a ratio. So this is going to equal some ratio. So we know that the sine of 2 theta is 2 times the sine of theta times the cosine of theta. We need to figure out what the sine of theta is, what the cosine of theta is. In this case, we've got a triangle. With a theta and the arc cosine of 3 over x, so the adjacent side over the hypotenuse, which is going to make the opposite side x squared minus 9, square root of x squared minus 9. So the sine of theta from this triangle is the square root of x squared minus 9 over x, and the cosine of theta from this triangle is 3 over x. So the ratio that we're looking for, okay, this ratio that we're looking for is this ratio, which is going to be this ratio, right? And that ratio is 2 times the sine of theta. And I know what the sine of theta is. The sine of theta is the square root of x squared minus 9 over x, and I know what the cosine of theta is. The cosine of theta is 3 over x. So I've got 2 times the square root of x squared minus 9 over x times 3 over x, which will be 6 times the square root of x squared minus 9 all over x squared. That's the answer to 39. Yep, indeed that is the answer to 39. So let's try another one here. Let's try cosine of 2 arcsine of x plus 1. Now remember, arcsine of x plus 1, the arcsine of a ratio is equal to an angle. So this is saying find the cosine of 2 theta. Well, I'm going to make myself a triangle with theta, right? So if this is equal to theta, then x plus 1 must be the ratio related to theta. So the ratio is going to be opposite over hypotenuse. So x plus 1 for the opposite, 1 for the hypotenuse. And then the adjacent side is going to be 1 squared minus the quantity x plus 1 quantity squared. And I think that that's going to be negative x squared minus 2x. But you can go off to the side and do it. If I'm wrong, you could fix it. But we'll say that that's what it is. I'm pretty sure that's what it is. Now the cosine of 2 theta is going to be a ratio. And that ratio is going to come from cosine squared of theta minus sine squared of theta using our double angle formula. That's what we used up here. We used the double angle formula up there. So the ratio that we're looking for is cosine, which is the square root of negative x squared minus 2x over 1 squared, because that's cosine. Let me write this a little bit bigger. My screen seems very small. Much better. Okay, so cosine squared. Cosine is going to be the adjacent side, which is the square root of negative x squared minus 2x, over the hypotenuse. And then we're going to square it. So we're going to square that ratio. Minus the sine of theta is x plus 1 over 1. And then we're going to square it. Right? So we square it and we'll get that. Now over 1 doesn't matter, right? So when I take this, love when that happens. When I take this and I square it, square root squared is just the radicand. And I'm going to have minus. I'm going to have parentheses because x plus 1 squared is x squared plus 2x plus 1. And then I'm going to distribute, so that's going to give me a negative 2x squared, and then negative 4x, and then minus 1. And I'm pretty sure that's the answer for number 40.